Welcome to part 3 of this push button test tutorial, push-button tutorial. In the last video we created these two event handlers using an interface. The next thing we're going to be taking a look at is how we can combine that push button we created, looking like this, combine that with our interactable logic here. Because right now they are separated. Okay, so first of all I'm going to delete all these guys here. If I can select it. Okay, and really what I want to do here is to create a specialized class based on the interactable here. So I'm going to right click this one and select create blueprint class, and I'm going to be calling this okay, that's a bad name. I'm going to rename this one to call this the old, and let's call this our button panel. Damn it. Okay. For some reason it saves a reference to that, so I can't really rename it right now. I had this issue, I remember, when I did this the first time as well. And I'm actually using a 4.12.3, so quite amazed that they didn't fix this one. Anyway, inside here we can see we get a few things by default, the build board and the collision sphere. And we get that from the base class, and the base class is found in here. You can see the parent class is interactable, so we basically inherit everything from that one, right? So what we want to do here is again to add two static meshes in this case, because it's a button that we want to create. In case it was something different, it would be something different as well. Actually, let me just call this panel, and this one button. So I'm just going to basically redo this as we did the first time, and button. There we go. And this time I'm going to select these two, and I can't select. Oh, I can select the billboard, but in this case I'm not really interested in rotating the billboard itself. It doesn't really matter since it's round, but I'm just gonna rotate this part here if I'm allowed, and I wanted to rotate it that way, I think. Okay, so right now it looks like the button is exactly at the middle, so that's great. That's where we want it to be. So let's compile this and save. And where is the button? Here it is. Okay, it's rotated wrong. Great. Okay, that's annoying. Hang on a sec. Oh, that was also wrong. All right, there we go. And also we want to make sure to scale this down here. So take these two and 0.5, 0.5, 0.5. See, there we go. So now we have combined the functionality of our interactable with the button itself. So now we can approach and see different panels show up whenever we are within range. Okay, so which one are we closest to, or which one are we actually looking at? How do we want to build this? If we go into the third person character, we have an array now. We can assume we have an array that shows us which interactables we are within range of. So if we use an event tick, and you might think, why use an event tick for this? You could also use a timer instead of an event tick, but for me it's just easier to just use an event tick when I prototype this. But I should actually get used to using a timer. I think that's something I will take up in a later video anyway. So what we want to do is to enumerate this list here. So we're going to use a for each loop and then try to figure out which of these buttons are closest to us, or we are looking most at. And the way we will do this is by taking a look at the position or the direction. If we look at our character, he has a facing direction, which you can see from this blue arrow. So he's currently looking forward. So he's still looking forward, although the camera is moving around him. So it's going to be a combination of which way he's facing. So in this case, he's facing backwards. Maybe if we end up standing somewhere like this, he's more or less standing backwards, but he's actually within reach. So in this case, I don't want to be able to push the button. I want him to be facing one of the buttons, because otherwise the animation will look really stupid. So I want to make two checks. One is to check if he's pointing more or less towards the one of the buttons, or the button, and the other one is the camera location. All right. So this array element, if we drag this one out, we can get a location of this one. So we get an actor location. Okay, actor location. So this is going to be get us a point in space where this actor is going to be, and we also have our own actor location, and our own actor location, I believe, is at the bottom of the collision sphere, or maybe it's at the center. I can't really remember. But anyway, this is not going to be the point that we're looking for. If you're ever in doubt which location this is giving you, you can always. I do this pretty often when I'm in doubt. I use a draw debug sphere. And the reason for the sphere is because it has a pretty big radius to begin with. So if I take this one, I can see, okay, so the center of the actor location is actually pretty much at the center of the character. But this also allows us to check something interesting, because if the center of the actor is down here, and we want to find an arrow pointing from that that middle position here up towards the button, to figure out if we're looking mostly towards that one or that one, and also combine that with the camera. You see, the camera is, we want to make it react when more or less the head is actually close to the camera, like this. So here we want to pick the left one, and here we want to start to pick the right one. And the approach I'm going to be using is going to be using a dot product to find the angle, basically, between two vectors, and then pick the one which is closest. So instead of using the axle location, I'm going to be using the socket location for the head. This. Actually, again, we can use the debug sphere to just check where this point is. As you can see, this is actually right dead center at his head. So that's the point I'm going to be using. Okay, so I want to find the difference, or the vector going from the button and to my head. Actually, I want it the opposite way around. I want it to be from the, I think, I'm actually not entirely sure. I think this is the vector I want to be getting. Let's see. It's so good. Okay, no, I will figure this out in a moment. Okay, and also, if you look at the way the camera, if you assume the camera, I can eject this for a moment. Oh, I can't see the camera, but well, the camera is somewhere here. So if you imagine a line going from the camera position towards his head, that's going to give us a position, an arrow. Look at this as an arrow pointing in that direction. So the head to the button has an arrow, and the camera to his head, or rather, let me see, yeah. The camera position to his head is also having an arrow giving us a direction. And you could maybe use just the camera control rotation, but I think I remember this gave me a little bit weird result. We can try that actually, and then revert to this. So sorry for all the blabbering. So get control rotation is basically giving you the control rotation of your camera, and get the forward vector is going to give you the forward vector of that camera. So if we dot these two together, this is going to give us an angle. Let's print this one out like this, and we want to make sure to pull this one up here. It's going to create a cast for us. So what this does is that once we get in within, nothing is happening right now because I forgot to connect this one up. It's going to give us two numbers right now, and right now it's just giving us one. And you can see usually you want to have a number between 1 and 0, and the reason for that is because this vector, this is a normalized vector. This is a vector going from 1 to 0, or -1 to 1, but this one isn't. So in order to get that, we want to normalize this one. Like that. And once we get in within here, we can see now the number is going from negative value towards positive value. And the closer we are to the button, facing the button, the closer this number is going to be to 1. So you want this to be as high as possible. So basically what these two numbers are saying now is that one of them is very close while the other one isn't. So if we gradually turn, you can see how these numbers switch. So now the bottom one is closer than the other one. And that information we can use to select which button we want to highlight. Okay. Since this is a loop, we want to save whenever we find dot product, which it is called. We want to save that into a variable and compare that in the next run in the loop here. So I'm going to drag this one out and promote to a variable, which we're going to set. Connect this one up. Yeah, it's good. And let's call this one the best interactable. Best dot product. Well, whatever. And we don't want to just set this. We only want to set this if this one is greater than the existing one. Okay. So if this, I need more space. This one is greater than the existing one, then we want to set it, and then we basically want to replace it with the new, better candidate. Okay, but the thing is, hang on a sec. Okay, so thing is, when we first enter this event tick here, this variable is going to have the value from the last time, the last event tick. So we want to start off by setting this to a very low value to make sure that -1 is probably going to be good. In that case, this means that the first time we're going to hit this one, it's going to be set to every time it hits here, it's going to set it to -1, and the first time it's going to find that dot product is probably going to replace that one with this calculated dot product. So what we can do now, instead of printing this, once we complete this one, we can print this best dot product like this. Whoops. And right now it's just printing -1. And once we get in here, you can see it only prints the high number, really. So that means right now we know which dot product is the best one, but we don't know which of these interactables it was. So we want also to save a copy to that. So drag a variable out, whoops, and all the way out here, and set that one also. Call this highlight, I think we called it. Highlight interactable, and that means that once we get out of the loop here, we can now print whichever button we are looking most towards. As you can see, the button panel 3 changed to button panel 2 when we changed the looking direction. So that's one part of it. The other part is that right now when we are facing, if I can do that, I'm out of reach. So right now it still detects that I'm looking at one of them, and we only want them to highlight. Right now it's highlighting by showing the name, but we only want to take them into account if we are facing the button. So that's the second part to this branch here. So we want to make a second check here. Okay, and for this check here, we want to check if the actor's location or the actor's rotation, which we can find from the get. This one, and get our forward vector, and we want to check if this dot product is greater than 0, because 0 means it's next to us really, and 1 means it's directly in front of us, and a minus value means it is behind us. So the direction we are interested to dot with is the difference between the button, or not the button, the interactable, and our head. That arrow, you can see. So this one is what you want to dot. And you want to make sure that this dot product so actually I pulled from the wrong one. It's got to be the normalized one. So this one has to be also has to be greater than 0. This has to be greater than 0. Like this. Okay. So let's try and see how that looks. So right now it says button panel 3, but it keeps saying that, and that's because we don't really reset the button panel, the best interactable. So if it had one at some point, it's not going to clear it once we hit this one first. So I'm going to set this to nothing to begin with. So you can see now nothing is showing up on the screen. So once I start to turn, so it's more or less to the side, now we can see the button panel 2, and now we can see button panel 3. But at this point we can't see button panel 2 because it's not we are not within reach. So now we are, and now we can select both of them. So that's a basic setup of this. I'm gonna be continuing in the next video to build on this, and stay tuned, and bye bye.